Okay. Hope everybody's having a good day, a good first day back. A few items before we go ahead and move on with the inverses. We have our next focus activity. I've got 3 guaranteed that are copied right now. I'm going to try to get at least a 4th and a 5th one. So don't turn them in until I go ahead and ask you to. So it's still going to be at least a good week, probably 2. But tomorrow you have our first quiz since being back. What's it going to cover? Graphing, okay. So just like the focus activity yesterday, you're going to have one problem where you're going to have to graph a transform sine or cosine function. Okay, very, very similar. In fact, the layout, the tables, everything is going to be the same. It's just a different function. And then following that, you're going to have a matching portion with all 6 of the trig functions. And then I threw a few extra transformed ones on there. So you'll just be matching the function to the graph. So hopefully that shouldn't be too bad. If you're familiar with the parents of all 6 trig functions, should be just fine. Okay, now the big one, of course, is coming up next Friday. What's that? That's your exam. Okay, so look for it to have some more questions on graphing. This one you're actually going to graph a trig function on there. Again, very similar to the focus activity, but it's going to be one of the other 4 trig functions. And then the remainder of the test is going to be on inverses. Jack?
It's on Friday the 7th.
Friday the 7th, yes, next Friday. Okay, so we still have a little over a week and a half. All right. So, test, we got the quiz tomorrow. Oh, one other thing I did want to go ahead and mention, just because I forgot to mention it the first period, but I did for second period. Who is our student teacher that comes in every Thursday? Okay, Miss Stern, Landry Stern, that is absolutely correct. So just to let you know that this Thursday is her last day with us. So she is going to be moving on to other things, but that's the reason I moved the quiz from Thursday when I normally have them to Wednesday. She is going to be teaching you the entire period on Thursday, so she's going to get at least one more opportunity to interact with you guys, and then she will say goodbye. Okay, so any questions? Okay, the only other thing I haven't mentioned, Friday morning is the deadline for what? The retake on the test before the break, yes. So this was one of the classes that had a failing average, so I encourage a lot of people to come in and do that. In fact, there was only one class, I believe, first period that had a passing average, and that's, nothing wrong with that, but, 4 weeks until the end of the semester, and grades are going to be finalized very quickly, so, take care of these items while we still have time. I already had some people come in this morning and ask me questions about the test. We reviewed it, and hopefully I'll have some more come in tomorrow, and we'll retake. Okay, well, let's take a look at our focus activity. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters, and Peter skates for 7 meters. How far apart are the skaters? Okay. Well, one thing I would probably do here, and this is just me personally, do what? I'd probably go ahead and draw a picture, kind of visualize what's happening. So these two are standing pretty close to each other. Jackie skates off and goes 5 meters, is that right? Okay. And then Peter goes off in his own direction. He's going to skate for 7 meters, and we're told that there's a 15-degree angle between them. And we want to know, once they stop, how far apart are those skaters? Okay, so pretty basic little design. Now, am I going to be able to use law of sines or law of cosines? Why can't I use law of sines? There you go. Remember, we need a pair. You need an angle and the side length across from that. So I need somebody to give me an equation that I can use to find x. Who can help me out with that? Okay, Christian. What do you want to call it? You want to call it A?
Yeah.
Okay.
A squared. 5 squared. Plus 7 squared. Minus 2 times 5 times times cosine.
Okay. He's absolutely right. Now, when I plug it in the calculator, I'm just going to want to change one thing. There you go. We want to take the square root of the entire expression. So if I come on over here and type in a big radical, 25 plus 49, I just simplified the 5 squared plus the 7 squared, minus 2 times 5 times 7 times the cosine. It was 15 degrees. Okay. How many meters am I looking at when I push enter? Okay. Hearing a few people whisper, about 2.5 meters. Okay. All right. So A is about 2.5 meters. They are apart from each other. Okay. How many people had that right before we talked about it? Good. Good, good, good. Okay. Remember, the retake is going to have the same material on it that the test did. I'll still let you go ahead and use that 3x5 card if you still have it. Okay. But it'll have law of sines, law of cosines, side angle, side area. Heron's formula could be on there if you wanted it to be. All right. But with the focus activity, go ahead and put that with number 1, someplace safe where you're not going to lose it. Going into the end of the semester, that is definitely a guaranteed grade. I'm going to record it again as a quiz grade. So we want all the good grades we're able to get. All right. Let's go ahead and get back to inverse properties. Now with inverses, let's go ahead and start with the big picture. I'm going to take all the elements in my domain, the x, all the elements in my range, the y, and what am I going to do with them? I'm going to flip them. The x's will become the y's and vice versa. That's the key idea for an inverse. But the thing about our inverses, we really, really want to make sure that they're functions. So our original function has to pass what we call the horizontal line test. And we started to see yesterday how with sine inverse in particular, we had to restrict the domain in order to make that happen. So we ended up with this input and output. Okay, remember we were talking about when you evaluate a trig function at an angle measure, you're going to get a ratio. You get the sides of a triangle. But if you're given the ratio and you want to work backwards to find the angle, you have to plug the ratio into the sine inverse or the trig inverse, okay, whatever you happen to be using, to get that angle measure. And we have, specific items here that we have to look at. Now, when you're trying to evaluate sine inverse, the only values of x I can input, the ratios have to be between -1 and 1. If they're outside that interval, it's not going to work. Your calculator is going to give you undefined. Okay. Now, your answers, okay, that you're going to get, they have to be between -pi/2 and pi/2. So what part of the unit circle is that? That was the right side, specifically what 2 quadrants? 1 and 4. Remember, sine inverse was only going to be found in quadrants 1 or 4. Now, how do we decide what quadrant it goes in? There you go, if the ratio is positive or negative, because sine is y, and y is positive in quadrant 1, it's negative in quadrant 4. And that's what we were looking at here yesterday, really emphasizing that sine inverse is going to be on the right side. And then using the ratio, we're going to create a right triangle. Now, we haven't gotten to one of these yet, but if the triangle you get isn't a special right triangle, that's when you got to get out the protractor and go ahead and measure to see what we're dealing with. And we're going to actually do our first ones of those today. But here's the relationship. If your triangle turns out to be a 45, 45, 90, the legs are always x units long, but the relationship is the hypotenuse is one of those legs times the square root of 2. In a 30, 60, 90, x is always across from 30. It's the shortest leg. The longer leg is the shorter times square root of 3. And then the hypotenuse is always double the shorter. So unlike evaluating trig functions on the unit circle, with these where you'd get normally, 1/2 square root of 3/2, here we're looking more at the relationship. We're not going to be getting those specific values. Okay, and I want to say we got through B, right? Okay, I think that's where we finished yesterday. What quadrant was he in? 4. Quadrant 4, because the 1/2 was negative. Okay, so let's go ahead and take a look at C. So this square root of 2/2 right here, if I'm trying to evaluate an inverse trig function, remember that's my ratio. Okay, so whatever the side lengths of my triangle are going to be. the length of the opposite, when I put it over the hypotenuse, this is what I should be ending up with. Okay, I'm really, really wanting you to make the connection that that's a ratio of sides. Okay, well, this is going to give me theta. Now, of course, you could work backwards. Say sine of theta is equal to the square root of 2 over 2. Again, you don't have to do that when you're working these problems. I'm just really wanting you to see, what's going on here. Okay. So somebody help me out. Is this going to be in quadrant 1 or quadrant 4 like the previous example? Okay. It's what? In 1. Why? It's positive. There we go. Okay. So I'm going to go ahead and draw my terminal side in quadrant 1. And I'm going to connect it to my x-axis, just like I always do with a perpendicular segment. So this measure theta, that's what I'm trying to find. Remember, we always start rotating from standard position. The only trick we saw yesterday, if it's in quadrant 4, you have to rotate clockwise, which is going to make your angle negative. It's really easy to forget. Okay, but we'll look at another one in just a moment. Okay, so sine, what are the sides that we always get? I forget again. Sine is what over what? It's opposite over hypotenuse. So we have the y over the r, right? Okay, wrong problem. So the y over the r. So here the opposite is the square root of 2, and the hypotenuse is 2. All right, well, to figure out if this is one of my two special right triangles, I need to find the third side. How do I do that? If I have two sides of a right triangle, I can use the Pythagorean theorem to find the third. All right, so let's say x squared plus the square root of 2 squared is equal to 2 squared. And what happens when you square a square root? Yeah, the right just cancels, so that's just 2 equals 4. So x squared equals 2. And then as we just saw with the focus activity, if I want x from x squared, I got to take the square root. Okay, there you go. So here's my question. Is this one of my two special right triangles? One of the big red flags, the two legs are what? They're exactly the same. So this tells me it has to be what? Has to be 45, 45, 90. 45, 45, 90. And we can go ahead and check it, one step further. You told me that the hypotenuse should always be the shorter leg times the square root of 2. Well, if I take a leg square root of 2 times the square root of 2, see, that does indeed give me 2. All right. So theta here is just 45 degrees. And if you were to look on the unit circle, on the right side, you're looking specifically for an ordered pair that has a y value of this. Okay, if you were to do that, you're going to notice it is at 45 degrees. Now, what if I asked you for radians? Yeah, but hopefully at this point we recognize 45 degrees is what? Pi over 4. But you can multiply by pi over 180 if you do forget that. Pi over 4 radians. There we go. Now see, just like we did yesterday, just like this one, if it's a special right triangle, well, really the majority of the work is coming from just creating the triangle. Because we're already familiar with those at this point. We spent a lot of time evaluating on the unit circle using the happy minutes. Now let's take a look at D. Okay. So it says sine inverse of 1/3. All right. So sine inverse is always restricted to quadrants 1 or 4. Zach, what quadrant will I be in? 1 or 4? 1, because the 1/3 is positive. So I'm going to do the same thing I just did. I'm going to go ahead and draw a terminal side. Use that to create a right triangle. So I'm looking for this measure right there, theta. Okay, now remember the side ratio. Sine is always opposite over hypotenuse. So y over r. So this is 1, this is 3. Okay. And now just like before, I'm going to use the Pythagorean theorem to find the missing side, right? X. So let's say x squared plus 1 squared, that's just 1, equals 3 squared? 9. So x squared would equal 8. Now, we are going to have to end up taking the decimal here, just to go ahead and get a more approximate measure, but I'm going to take this opportunity just in case. If I did want to simplify this but keep it as a radical, what would it be? 2 square root of 2. Yeah, you're looking for the largest factor that's a perfect square that'll evenly divide your radicand. So x is 2 square root of 2. All right, good. Okay, now we got our triangle. Does anybody have any questions on that? How we knew it was in quadrant 1, how I found the 2 square root of 2, anything. Okay, now here's my next question. Is it one of my special right triangles? Okay, well, how do we know immediately it's not 45, 45, 90? The legs are not identical, so that one's out. Just look at one relationship here. We know it's not a 30, 60, 90 because the radius, the hypotenuse, should be double the smallest side. And 3 isn't double 1. Okay, so this is where we're going to have to take out a protractor and actually measure to find what the angle is. All right, so I've already got that set up here. Okay, so let me go ahead and kind of redraw this. We had 1, 3, and we found this to be 2 square root of 2. Now, what I like to go ahead and do is use centimeters. But if you want to go ahead and use inches, that's perfectly fine. I think it's going to take up more space. I think centimeters is just a better way to do it. But if you want inches, you're more than welcome to. So I'm going to go ahead and say that all of these units are in centimeters. Okay. Now, the height, the 1 centimeter, that's going to be real easy to take care of. But we've got 2 square root of 2 centimeters. So now let's take the decimal value. 2 square root of 2. So I'm looking at about 2.8 centimeters. Okay. Well, because of the instrument I'm using, I'm going to want to convert this to millimeters. Okay. So how many millimeters are in 1 centimeter? Oh, not 100. Okay, 10. There we go. So 1 centimeter is equal to 10 millimeters. Okay. So here's the thing. If I have 2.8 centimeters and I want to convert that to millimeters, well, what am I going to do? Real easy. Do what with the 10? Just multiply it by 10. There you go. So times 10, but we know that's just going to move the decimal. So I'm looking at about 28.3 millimeters. Okay. So I'm going to go ahead and convert these. This one here is going to be about 28.3 millimeters. This one's going to be 10 millimeters. And so we know we're in quadrant 1. I just now need to go ahead and measure this out. Okay. So let's see here. Got my ruler ready to go, and if your protractor has a ruler on it, that's perfect. So I want to go 28.3, and every centimeter is 10. So 10, 20, 25, 26, 27, 28.3. I'd say maybe right about there. Would you guys agree where I put my dot? Okay. Now, so I don't have to continually rotate this back and forth, I'm going to take the other one, which is already vertical, and I want to go ahead and this will move down just slightly. I want to go ahead and get 1 centimeter. Okay, so I'm going to measure 1 centimeter right there. Okay, so I've got my marks. Let me go ahead and draw my sides here. There's 1. And I'm going to go ahead and draw these longer because remember, I want to go ahead and see easily what the value on my protractor is. Is everybody okay with what I've done so far? Okay. This is the 28.3 millimeters. This is the 10 millimeters. And I'm looking for this angle right here, theta. Now, I don't want to insult anybody's intelligence, but this has happened. Is there anybody in here who does not know how to use a protractor? Okay, so I'm going to take the crosshairs of my protractor, and I'm going to go ahead and put it right on the origin of my coordinate system. That is, of course, if I go ahead and get rid of that. There we go. So let's see here. I'm going to put the crosshairs right on the origin. Okay. So what angle measure am I getting? What would you put as your answer? $25? Huh? It looks to me like it's hitting, well, of course it changed it, but it looks to me like it's hitting right about 20. Would you guys agree? Okay. So I'm going to say that theta is right about 20 degrees. Now, let's go ahead and check, because here we're measuring it by hand, so are we going to be exactly right? No, but the calculator is going to be exact itself. So let's go to the calculator. We were looking at sine inverse of, what was this, 1/3? 1 divided by 3. Let's see how close we got. Bam! 19.5. So we got really close to what the measure should be. Okay. Now, I'll go ahead and tell you that I'm in the process of creating the test for next week, and I've already got several problems on there where it's not going to be a special right triangle. You'll have to use a protractor to go ahead and measure and get this. So what I'm already thinking of doing, just in case, somebody measurements is a little off, which is perfectly plausible, I'm going to go ahead and give a range of 5 degrees above and below. Okay. So if I'm saying which I think should be more than enough to compensate for an error you might make in measure. Okay. All right. Now, one other thing, let's say that I go ahead and ask you for the measurement in radians. We don't have to change the mode on our calculator. What can I simply do? Yeah, just go ahead and multiply it by pi over 180. There we go. So I'd say it's about 20 degrees or about 0.34 radians. Okay, so either one should be really, see, I don't have to change the mode. It's still always going to give me degrees. Isn't that right, Xavier? All right. Now, let's go ahead and try another one of those. Let's make sure you feel comfortable. Okay. Let's come back over here. Now, I'm going to go ahead and give you a couple minutes to look at this one on your own. Get rid of this. All right. So try this one. Now, you should be okay with the measurements. I don't think that is really going to be the issue. Sine inverse of, let's say, -3/5. Okay, so I'm going to go ahead and give you an extra problem. I'm going to tell you this is not a special right triangle, so you are going to have to measure it. Okay. Sine inverse of -3/5. Now remember, think about your restrictions. The ratio that you plug into sine inverse, it has to be between -1 and 1. So first off, is this going to work? Yeah, -3/5 is definitely between -1 and 1, right? Okay. So if the input's okay, remember my answer has to be on what interval? And if you're not sure, remember, look back to the front of the packet. This right here is my input, my x values. So this right here is my output, the y values. So it has to be between -pi/2 and pi/2. Okay. Now there's also one other thing. What quadrant are you going to be in? Quadrant 1 or quadrant 4?
4.
Why 4?
Negative.
Because it's negative. So remember, once you find that angle, you're going to have to make it what? In quadrant 4, we rotate clockwise, which means your angle would be negative. And again, it's something really easy to forget. Okay. All right, so let me go ahead and give you another minute on that, and then I'll catch up to you. And then we'll go ahead and start taking a look at cosine. And remember, don't go to the calculator just yet. Okay? Try to use your protractor. You want some practice on that, because I haven't officially made up my mind, but I'm really thinking that the test next week, no calculators. Ooh, I got some dirty looks on that one. Okay. That's why I want you to practice this. Okay. -3/5, yes. -3/5 is what we're trying to evaluate. So let me at least catch up to make sure that everybody has the correct figure. So Connor told me we're in quadrant 4 because it's negative. I'm going to create my right triangle. Okay, we're looking for this angle right here. Now sine is always opposite over hypotenuse. So the y over the r, which one's negative? The 3. Remember the radius, that hypotenuse will never be negative. So he has the negative. Now you can use the Pythagorean theorem, but I'm hoping you recognize this as a triple. This is a 3, 4, 5. Even if you didn't, you should still be getting 4. Everybody at least get the diagram. Okay, good. Now that all that remains is to actually measure, if I were doing it, 4 centimeters by 3 centimeters, and then get the angle. Okay. And then once you have that angle measure, then plug it in the calculator. Let's see how close we got. Let's see if you're pretty accurate or just a little bit off. Okay. All right, so I see a lot of people going to the calculator, which tells me that they have gotten their measure. So I'm going to catch up again. So from the origin, I want to go 4 centimeters to the right. I mean, if you wanted to convert this to millimeters, you can. It's still going to be the same distance. Okay. And now I want to go 3 centimeters down from that point. Okay, so 3 centimeters. Let's say right about there. Okay. All right, now I'm going to go back and mark where these are. There we go. Okay, so that one there is a little off. There we go. All right, now I'm going to have to rotate this guy. Turn him upside down. I'm going to place my crosshairs on the origin. Oops, there we go. Okay. All right. I think my measurement was a little further off this time. Looks like I'm getting about 40, maybe even 41. Okay. About 40 or 41. Let's see how close I got. I think I'm a little bit ways off. So I'm going to say sine inverse of negative 3 divided by 5. So about 37. Okay, so I was a little bit further off that time on my measurements. Second period is the only time so far I've been perfect for both examples. Of course, the class I'm recording is the one that I'm off on. But would that still be acceptable as an answer? If this is what I had on my key, but I put, say, negative 40. Remember, we're going 5 above and 5 below. Okay, so a good range. All right. In fact, again, why would it be negative? Remember, what quadrant are we in? We're in quadrant 4, and we have to rotate clockwise if we're in quadrant 4. How many people got that right? Good. That's the most hands I've had all day. Good, 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 good. Okay. Let's go ahead, put sine inverse to the side. Let's go ahead and talk about cosine. Cosine inverse. Okay, how do we get the graph? How are we going to know where to find him? All right, well, these are the same steps we went through yesterday in trying to figure out sine inverse. Okay, so first, let's graph cosine. Here's my origin. Let's say pi, 2 pi, negative pi. Let's see here. Does cosine start with a 0 or a maximum? Maximum, there we go. So cosine starts with a maximum. Then I have 0 minimum, 0 max, 0 min. I'm going to go in the other direction as well. Okay. All right, there we go. Is this function one-to-one? If I were to go ahead and put a horizontal line through, no, he fails a lot. So if I take the inverse right now, the inverse is not a function. So what we're going to do, just like with sine yesterday, we're going to restrict his domain. We're going to cut part of the graph away so that he does pass the horizontal line test. Okay, so first, let's start with the range. So what's the range of cosine? Yeah, the lowest it goes is -1. The maximum is 1, right? So -1 to 1. Okay. Now, these are the same two questions we asked ourselves yesterday when dealing with sine. What domain value, or x value, will give you a range value of -1? Now, let's go positive on this one. What's the first positive value that gives me -1? Yeah, it's pi. It's right here, right? So that's pi. What domain value, which x, will give you a range, a y value of 1? 0. As soon as we start out at the origin, you already have that positive 1 right there. Okay? So here's what I'm saying. We're going to go ahead and restrict his domain to be between 0 and pi, right? And we said that his range is from -1 to 1. Would everybody agree? So I'm going to cut this off. I'm going to cut off the left side right here, and I'm going to cut off the part to the right of pi. Okay, so here's 1. There we go. Now if I were to put a horizontal line through him, would he pass? Yeah, he's definitely 1 to 1. So the inverse is going to be a function, right? Now, let's come on down here where we're going to graph cosine inverse. Remember, what's the big idea for an inverse? We do what with the x's and y's? We flip them. So the domain of cosine is going to become the range of cosine inverse. So this will be 0 and pi. Okay. The range of cosine will become the domain of cosine inverse. So this is between -1 and 1. Okay. Do those look familiar? If you take a look at the front of your packet again, you'll notice for cosine inverse, those are his restrictions. Okay, so the good news is the ratio, just like sine inverse, still has to be between -1 and 1. It has to be in that interval if you're going to evaluate it and get an answer. But what's the difference? Your answer, your degree or your radian measure, has to what? Where does it have to fall? Between 0 and pi. Okay. So if we're looking at the unit circle, and let me just go ahead and fill in these right here. We said that the domain is between -1 and 1, and the range is 0 and pi. So if I'm looking at the unit circle, here's standard position. Okay. Here's 0 radians. Here's pi. What part of the unit circle is cosine inverse going to be restricted to? The top half. Sine inverse was restricted to the right half, quadrants 1 and 4. Cosine inverse, he's restricted to the top half, which are what two quadrants? 1 and 2. Okay. So we have the same input, but we're going to be looking for different quadrants. Cosine inverse can only exist in quadrants 1 or 2. Well, how am I going to know what quadrant to put the triangle in? Positive or negative. Remember, cosine is x, right? X is positive in the first quadrant, but it's negative in the second quadrant. Okay. Let's go ahead and finish up with the sketch. Let's see here. The domain is now -1 to 1. We have 0 to pi. And remember, to kind of help you flip this, you could just invert the points we still have on the original. Like, for example, this one right here, this is pi -1, right? So what would he be on the inverse? -1 pi. This point right here is a 0, 1. So he would be 1, 0. And we could even use this one here in the middle. Pi over 2, 0. What would he become? 0 pi over 2. So we're going to have something that looks like that. And that's a 1. That the graph doesn't keep going. So there's the graph of cosine inverse. Okay. I can only evaluate him with x's between -1 and 1. I can only get answers between 0 and pi. Okay. Now, the fact that we're about to evaluate cosine inverse makes absolutely no difference. You're still going to choose the right quadrant, draw your triangle, and then hope that it's going to be a special right triangle. If not, then we'll use our protractor. Okay. Now, before we do that, let's go ahead and revisit those triangles one more time. 45 degrees, 45, 30, 60. So the side lengths of a 45, 45, the legs are x. Let's see here. Raphael, how does the hypotenuse relate to its leg? It's always that leg times square root of 2, yes. In a 30, 60, 90, x is always across from 30. So Xavier, how is the longer leg going to be related to the shorter?
So it's going to be above, or not above. Like, what do you ask?
Well, I'm asking in terms of x, what would the length of the longer leg be?
The ratio of those two shorter.
Well, if you're taking a trig function, you take a ratio. But there's just one thing I need to multiply x by to have this length.
2.
Not 2.
Square root of 3.
Square root of 3. You're half right. Forget the last part.
Square root of 3.
There you go. So x times the square root of 3. Okay. And then the hypotenuse is always double the shorter leg. Okay. All right. Well, let's try a couple of problems. And this will actually be where we stop today. Let's try A and B. I want you to go ahead and try those on your own. I'm going to give you 2 minutes to work through this. Okay, now I'll go ahead and tell you that B should turn out to be a special right triangle. You should recognize it as one of the two. So you shouldn't have to measure here. In fact, the next time we'll have to measure is when we get to D. Okay, but we'll get to that tomorrow. So A and B. Let me go ahead and give you a couple of minutes to practice this. You really want to practice it because what is this material going to show up on? Test. Remember, while sine inverse has to be found in quadrants 1 or 4, cosine inverse will be in quadrants 1 or 2. Has to be between 0 and pi. Now, I am going to go ahead and give you one hint on B because a lot of people have been missing this one today. Remember, cosine inverse, just like sine inverse, you have to start rotating from standard position. So I already see some people erasing. Here we go. All right. Okay, so that's 2 minutes. You may not be done, and that's okay. Cosine inverse of 0, we're looking for theta. Can anybody tell me what answer they got? 90 degrees. It is pi over 2, yes. Okay, so a couple of ways. You probably could have just looked at the graph we just drew of cosine inverse to figure out what that was. But let's say you went the triangle method. Well, what quadrant am I going to put this in? Would it be 1 or 2? And see, we have a problem because 0 is what? 0 is, neither positive nor negative. So let's just say, put that aside. Let's say I still go ahead and try to draw a triangle. Okay, so I have theta. Now remember, 0 is the same thing as 0 over 1. And cosine is always the adjacent over the opposite. So the x over the r, right? So this would be 0, this would be 1, and do you see where the problem is? We have a side length of what? 0. So if you can't create a triangle, it has to be a what? Starts with a Q. It has to be a quadrantal, just like we did on evaluating the unit circle. So really, if you're thinking about the unit circle, and remember, I'm restricting myself to the top half between 0 and pi. Okay, you're looking at all of these ordered pairs. I want to know the one ordered pair where the x value is 0. And that only occurs in one location. Right here at pi over 2 or 90 degrees. Okay. How many people got that one right? Okay, did we get close? All right, let's try B. Okay, so cosine inverse of a negative 1/2. Am I in quadrant 1 or 2? Okay, 2, how do I know? It's negative. Okay, so I know the quadrant, so I'm going to draw my terminal side, connect it to the x-axis just like I've always done. Okay, now remember this is x over r, so this is 1, 2. Which one's negative? The 1. The radius, the hypotenuse will never be negative. Okay. So now let's go ahead and see what that missing side length is. We're trying to find the y. So y squared plus a negative 1 squared is equal to 2 squared. So y squared plus 1 is equal to 4. So y squared should equal what? Okay, 3, and then ultimately root 3 when you take the square root. Okay. And here's my question. Is this a special right triangle? Yeah, in fact, it's 30, 60, 90, right? Okay. This would be 60. This one would be 30. And now don't let the negative throw you off. The negative just tells me the direction we would move. The hypotenuse is still double that shorter leg, and the other leg is just the shorter times the square root of 3. You're just not worried about the sign. Okay. So what's my answer? 60? It is not 60. It is 120. Remember, what was the hint that I gave you? Just like sine inverse, you always have to start rotating where? From standard position. So the only way to get over to quadrant 2 is by taking that angle. So your answer should be 120 degrees, or what would that be in radians? 2 pi over 3? Okay. And we can confirm that. Now if I go to my calculator, if I take in cosine inverse of, what was it, negative 1 divided by 3? Or was it negative 1/2? Negative 1/2. Bam, gives me 120. Okay. Now you might be asking yourself, well, why do we do it that way? Well, just cause. Just cause. Cosine. Yeah, okay. Well, we're going to go ahead and stop there. So here's the thing. One thing I want to go ahead and throw out there very quickly. If it's sine inverse and in quadrant 4, you have to rotate clockwise, the angle will be negative. If it's cosine inverse in quadrant 2, you still have to rotate all the way from the standard position. It won't be the reference angle. Okay, we have less than 2 minutes. I need all my calculators back up to the front. And if you borrowed a protractor or a ruler, I do need that over on my other desk, please. I need to see all the calculators up there before I can let you go.